All right, for these notes are going to continue with identifying the null and alternative hypothesis in that first, or actually the second step of phantoms, the H. And so we're just going to kind of continue on with that today. So first of all is a lot of times you will be given a statement or like a paragraph of information, just like we've seen before with confidence intervals. And so the process is to just kind of make sure you know what the claim is and then put it into symbols. And so once again, symbols can be using any of these right here. And then let's see, the complement of the original claim, the opposite of the claim is going to be the alternative hypothesis there. And so just kind of recognizing those two things. So identify the claim that's to be tested, that will be our null hypothesis, and then the complement of that is the alternative. So that's why this often is going to be not equal to, or excuse me, oops, I should erase. It's going to be equal to, but then this one technically isn't always just the complement. There could be a phrasing that says, hey, I'm only interested in greater than or less than, that kind of thing. So you kind of have to be careful with that complement idea. So we'll do this, of course, with some practice and examples in a few moments. But writing the null hypothesis, this symbol right here, it will often be the equal to, like this right here. That's exactly what we're looking for. The null hypothesis, right like that. Depending now if you're using a symbol of if you're doing proportions or means, that will change then what you do there. You might have my mean equals some number, or you're going to have your proportion, your population proportion equals some number. So we'll look at that in a moment. Then the alternative hypothesis, you are going to be using this symbol. Let's see here. So this right here, and then there's three different ones because it's not going to equals. So it might be H1, and then you might have, once again, not equal to, you could have H1, and then you could have greater than, or you can have H1 and less than. And of course, each of these parts right here and before that are going to either have a mu or a p here. And same with this one right there. And then you're going to have a number. And that number you're going to have over on the other side is going to be the exact same number you had in the null hypothesis. So here is an example. Unfortunately, I don't like that they have a bunch of this already shown to you. I'd like to kind of give it one step at a line when we're in class, but we'll just make do right now. So this one does have a claim about a standard deviation, so that's good for us to just practice with it, but I will not be giving you any full tests of significance that you'll have to do using standard deviations. We're going to focus mostly on proportions and on proportions and means. So here we have the standard deviation. Sorry, my daughter is playing right next to me, so you hear some sounds from her. She just dropped something. The standard deviation of duration times in seconds of the Old Faithful geyser is less than 40 seconds, okay? So hey, we're told about the standard deviation. So hey, that's the claim right here. Now, I don't particularly like this because the claim is usually it says less than, sorry. So the complement then in this case would be anything that's not true, or I'm sorry, not true, but not the opposite, I guess you could say, so that you get all possibilities. So less than, so then this has to be greater than or equal to. Now, I don't necessarily like doing these two steps. I think it's easier to just kind of go straight forward to these ones. The null hypothesis, even though it says it is less than here, you're still going to use equals to in this null hypothesis. All right, and so we're using this symbol here because that's our symbol for population standard deviation. And then the alternative hypothesis, we're going to use that as less than idea. And so that's why you have that symbol there. So sometimes I kind of skip that because that doesn't always make sense to me. All right, and then here's another one. The proportion of homes with fire extinguishers is 0.8. So I like this one a little bit better. Once again, I kind of just go straight to these ones. I don't necessarily do these two steps myself, but okay, we're told proportion. So I think, okay, I have to use this symbol, and then it is 0.8. So, hey, the null hypothesis, I'm always using this equal to. And so hopefully that makes sense. I use the symbol H0, H naught technically, and then my proportion. So I have to use P, and then what does P equal? We're claiming it equals 0.8. The alternative hypothesis then, notice that it just says is, so what's the kind of the complement of that, or there's no direction of saying, hey, I think it's less than that, or I'm suspicious and I want to explore if it's greater than that. So when you're not kind of given any information, you would do something called a two-sided one where it's not equal to. And we'll talk more about why it's two-sided as we continue on in this unit. So hopefully you remember that H1 is the alternative hypothesis, and I'm totally fine if you don't make this like a little one, a subscript there, that's okay too, especially if you're doing something electronically in these next couple days. So the hypothesis test always tests the null hypothesis, right? And this was kind of alluded to as we've done a few examples kind of like this in the past. But the idea is we are always going to assume the null hypothesis is true. And then you are going to gather your sample information and see if that sample information is strong enough. In other words, I have a small enough probability of this getting this sample if my null hypothesis were true. And so, hold on, sweetie, I'm on this, okay? Excuse me, we assume the null hypothesis is true. Then if you get your sample that is so unlikely to happen, then that's when you're going to decide, hey, maybe I'm going to reject this null hypothesis because of the probability, or maybe you're going to fail to reject the null hypothesis. In other words, you're accepting it, you're thinking it's true, but we never, ever, ever use those vocabulary word accepting. You always use reject or fail to reject, which I know seems a little odd. We'll talk a little bit more about that later too. And so those are the two choices you have at the end of a test, and that we'll get to when we get further along in our phantoms steps. But you're always assuming the null hypothesis is true unless you have strong enough evidence to suggest otherwise. So let's try a little bit more. Example here, the claim is that the mean body temperature of a human is less than 98.6 degrees, and you randomly sample 100 people, and they have a mean temperature of 98.5. Now here's where you have to be super careful. I'm given two numbers, well technically three numbers. One is the random sample, so this right here would just be my sample size, so that's n. But I'm giving these two numbers right here, so how do I know which one I'm using for my hypotheses there? What do I know for the null hypothesis? First of all, it says mean, and so we know a mean, I have to use this symbol right here, the mu, but then you can clearly see I have written down it's 98.6. Why do I know it's 98.6 and not the 98.5? Is because this is what the claim is, that the mean body temperature of the human body. So of all humans, hey, this is the temperature, while in comparison, this 98.5 is for just a sample. This symbol right here is for a population, not for a sample. So you're always going to have your hypothesis with not the sample symbol, but a population symbol. And so that hopefully makes a little bit of sense. Now, I don't necessarily like this example for the alternative, but you have your random sample has a mean temperature that's less than. Normally you wouldn't use, technically it's cheating to come up with your alternative hypothesis by using your sample information, but we're going to kind of go with it right now. And so see how it's less than, this 98.5 is less than my body, the temperature that they're claiming it to be. So in my alternative hypothesis, I'm going to use this less than symbol here. I'm using the exact same number in both of them. And I'm just changing this little 1 and this little 2 and the symbol as well. Those are the two things that get changed. So then here's our unofficial decision. This is a step that we're going to get to later. But basically, this is pretty close. 98.6 and 98.5. So that is 0.1 off, right? Sure, it was in a sample of 100 people, but to be 0.1 off, we're going to learn eventually how to get that probability that that's likely to happen or not. But I'm going to just tell you right now, but basically that's not far enough away from that mean that it still could be true, and it still is going going to be pretty high probability that that claim that the mean body temperature is 98.6 degrees is true. So I would say that there doesn't appear to be sufficient evidence to support the claim. And now that phrasing we're going to get into a little bit more, and I'll have some kind of templates, I guess you could say, that will help us in this regard. So we're failing to reject, if we went back to the previous slide, our null hypothesis. And last example here, artists are more likely to be left-handed than 10% of the general population. So in other words, they're saying that, hey, the general population has 10% that are left-handed, but artists, we're thinking that they have a higher chance, right? More likely to be left-handed. So our hypothesis right here is the equals. So proportion, right? It's a percentage. So I gotta think proportion, P, and I convert it to a decimal. And then I have, then we're thinking that, hey, they're more likely. So I'm thinking at that phrasing, that's where I'm going to use that in less than, greater than, or not equal to. And so because more likely, I would then put the 0. So here then we have an architecture found 18 of them are left-handed in a sample of 50. Okay, so if I had a sample of 50, one second, Charlotte, I'll help you in just a second, okay? In the sample of 50, I have, let's see here, I would find out my p-hat essentially. My p-hat is going to be 18 out of 50, right? Which gives me, I'm hoping this is true, 0.36. Okay, so 0.36, that is quite a bit higher than that 10% claim, right? 36% that would be. So that's quite a bit higher. And once again, we're going to get to finding out what is the actual probability of getting 36% of a sample of 50 having are being left-handed later. But for now, hey, that's a big enough of a difference that I would think, hey, my claim probably isn't true. In fact, artists are more likely to be left-handed. So I'm going to reject it, and then I say there is sufficient evidence to support the claim that the population proportion is greater than 10%.